Okay, this lesson is over friction, where we're actually using coefficients of friction. And if you have never seen this before, uh, there are basically two types of friction. There's static friction, there's kinetic friction. So you'll have to make sense of that, try to think of a time where you try to move some very big, heavy object. And you might have noticed that as you're moving like your dresser in your bedroom or your bed in your bedroom, something like that, we're trying to move it from one location to another. You might notice that you push against it, against the object, and it doesn't move. And so if I draw a free body diagram, let's say here's the object, here's the gravitational force, here's a normal force, and we are pushing on it with the force Fp, and it's not moving. If this is all we drew, it would accelerate, but remember that, let's suppose that it's not moving. That means that there is some friction force that is matching your pushing force, and we call that static friction. So static in this case means not moving. And the maximum amount of static friction is given by this equation. Fn is the normal force, which you all know is this force right here, which oftentimes is equal to the weight. So that makes sense. If you're trying to push your fridge, for example, well, it's got a lot of mass, and so the normal force is very large. That's going to increase the amount of total, that static friction that's there. If you have an object that weighs less, then the normal force will be less, and there will be less friction, and maybe you can push it more easily. So forgot to mention, this is a new term here. This is a Greek letter called mu. It's not m, so don't do something like this. It's more like a U with like a stick on the other side. Now, it does look like an M, but it's not an M. And what mu represents is the coefficient of static friction. Mu sub s is the coefficient of static friction, which there are no units, by the way. For forces, you know that those are newtons. And I'll briefly explain what the coefficient of static friction is. It's basically a number that's determined by the two surfaces in contact. So I want you to imagine a dresser in your bedroom. Let's say it's made out of wood. And let's say your floor is tile. Well, that number would be some number typically less than 1, might be, let's say, 0.4. But suppose now there's carpet in your bedroom. And so it's now wood against carpet. And you can imagine that there's more friction between wood and carpet, right? Well, that means that this number would be greater. So this would be like 0.6, 0.7, something higher. And typically these numbers are less than 1, but the higher it is, the more friction there would be. And then finally, Fs max, this is the maximum static friction force, which is in newtons. So this is the force that I have to overcome. I need to push with more force than the maximum static friction if I'm going to get this thing to move. So let's suppose we do that. You're in your bedroom and you're moving your dresser, and now you finally push with enough force where you get the object to start slipping, and now it's moving. Now there's still friction, but we call that kinetic friction. So here we'll just make a little note and say that kinetic in this case means moving, because it's just moving. So if we want to calculate the force of kinetic friction, that would be Fk equals mu sub k, it's a different number, times Fn, the normal force. And this is the coefficient of kinetic. So can I do this? Coefficient of kinetic friction, which again has no units. This number is typically smaller than mu sub s. So mu sub s and mu sub k, this one is typically greater than this one. Once you get that object to start moving, it's typically easier. There's less force involved to get it to move than trying to get it to move in the first place. As usual, doing an example really kind of gives us more sense than just defining everything. So we have a 33 kilogram dresser. It's at rest on the floor. The coefficient of static friction is 0.77. And the coefficient of kinetic friction is 0.54. And we might as well write that the mass is 33 kilograms. And I'm going to steal this free body diagram because this will be typically what we see for these problems. Actually, it's part C. So we'll just do part C right here. So when doing these problems, they look long, they look complicated, but A and B are going to be together and D and E are going to be together. So let's do this. Part A, what is the maximum force of static friction? So we'll use our equation. Fs max, the maximum force of static friction, is equal to 0.77. I'm pulling that from over here, from the problem, times Fn. So what is that force? Because the object is not accelerating up or down, it's just a dresser in your bedroom. It's not accelerating up or down. Fn will be equal to mg. And that's something that for this assignment we're just gonna always use. In fact, I'll do this in a different color. And so we take the mass, 33 times g, that's 10. So that's 330. So that's 0.77 times 330. That's 254.1 newtons of force. So remember, this is the maximum force we must push with. I'm sorry, this is the minimum amount of force we need to push with to get an object to move. We have to overcome that force. We have to be greater than that force to get it to move. So if my pushing force is only 200 newtons, but my maximum was 254, I have not met the maximum amount of friction force. So for question B, does the box start to move? We say no. We can say FP is less than Fs max. Otherwise, we would have said yes. So that's A and B. They kind of go together. If I'm just saying for your assignment, let's say we push with 300 newtons of force, FP. Then we exceed this and we would say yes, FP is greater than Fs max. So that's A and B. Let's do part D and E. Let's suppose now, when we do the second part, we're supposing that it's moving now. So forget about whether it will or will not moving. Let's say we push with enough force that it's moving now. Just plain and simple, just moving. Now that it's moving, let's calculate the kinetic friction force, which is mu sub k times Fn, which nothing has changed about Fn, that's still mg. And so Fk is equal to, here I'm going to do this in a different color, mu sub k, which is 0.54, again from the problem, and mg is still 330. So the friction force is 178.2 newtons. And so finally, the dresser is now moving. If the dresser is being pushed with a force of 205 newtons, what is the dresser's acceleration? So I'm looking here at the free body diagram. It's going to accelerate in this direction. We're going to use our pushing force of 205. And when it's moving, that's kinetic friction, it's not static friction. So we'll be using Fk as our friction force. And so the way we solve this is we say the sum of all forces equals ma, and we are looking at the horizontal forces. Which is Fp minus Ff equals ma, and we are solving for a, and so we'll divide both sides by m. Fp, remember, is now the 205. Ff is Fk. This is Fk because it's kinetic. And so that's 178.2 all over the mass, which is 33. So we get an acceleration of 0.81 meters per second squared. And that's typically it for these problems.